Okay, alright, thank you. Okay, so saya akan memulakan pembentakan saya hari ini dengan memberikan gambaran keseluruhan mengenai sasaran nasional kita terhadap pengurangan karbon, beberapa peraturan yang berkaitan dengan tujuan ini, menentukan bangunan hijau dan standard persijilan sebelum melihat beberapa ciri-ciri fokus utama dalam penghijauan bangunan komersial. Okay, izinkan saya meneruskan dalam bahasa English. Okay, so basically we have national targets for the reduction of our carbon emissions intensity. We have to hit 45% reduction from 2005 levels by 2030. Now the built environment contributes about 30 to 40% of this total GHG emissions through the design, construction, cooling and illumination of buildings. Approximately 8 to 10% of this is embodied. It is implicit in the building materials and the construction processes in developing the building. But 20 to 30% of this is operational, which comes through the life cycle of the building. And the bulk of this is due to electricity consumption. Okay, if we go to the next slide. Okay, so it is no surprise that the focus at a regulatory level, at a policy level, even through voluntary standards that are there, has a strong focus on energy usage. We have the minimum energy performance standards for domestic appliances. This is the rating standards that ST uses to label basic domestic equipment. For larger commercial and industrial consumers, we have the EMIR, efficient management of electrical energy regulations. Then we have two voluntary standards I think most of you will be familiar with, MS 1525 which is energy efficiency standards for non-residential buildings, and MS 2680 for residential buildings. Currently, as A.R. Chan mentioned earlier, UBBL 38A, there's amendment to the UBBL. However, this has only been gazetted in 3 states so far. I think we look forward to it being gazetted across Malaysia, which has incorporated some elements of MS pertaining to energy into it. And upcoming, we have the Energy Efficiency and Conservation Act. I think this is currently still being run through or debated in Parliament, but effectively when this comes through, we will be setting energy performance standards for various industries. Okay, and we move to the next slide. Okay, this has been covered earlier, but just in summary, just quickly, what exactly is a green building? Basically, it's a structure that is designed, built, renovated, operated, reused in an ecological and resource efficient manner. And sustainable development, this is very important. It is about maintaining the delicate balance between our need to improve our lifestyles, the feeling of well-being, and also preserving the natural resources and ecosystems. So it is about approaching the whole matter in a responsible way. Okay. Now, before I go into what we do, I think we talk a lot about green buildings, but how do we define these buildings? So we need standards for that. So basically, standards are established by consensus, approved by a recognized body that provides for common and repeated use as rules and guidelines. These standards can either be prescriptive, performance-based, or outcome-based. So I think the best way would be to have all three included. So we should be highlighting what needs to be done and then measuring this. Now that is the standards alone, but we need certification as well. I think if it's not independently verified, it doesn't get done. So that is why I think standards, development and certification should go hand in hand. Okay, next slide. So that is where REHDA has set up Green RE, which stands for Green Real Estate. We develop standards for green buildings, and we also do certification. To support that, we have a lot of training activities where we have accredited facilitators to undertake these activities. Our standards have been adapted from Singapore Green Mark, which is an internationally recognized certification tool. And to date, we have certified more than 200 projects in Malaysia. Okay, next slide. Okay, when we talk about green buildings, universally, I think there are 6 major pillars. The most important one would be energy efficiency. Here we look at both passive and active design. We also look at incorporation of renewable energy into a building. Then we look at water efficiency. This is growing in increasing importance here in Malaysia. I know we have an abundant amount of water, but we should be doing our best to conserve this resource. Environmental protection, where we look at sustainable construction, the integration of sustainable products, incorporation of more greenery into a building. I think when we look at TODs, high density, especially in urban environments, we should look at creative ways in which to incorporate greenery. So we use something called a green plot ratio to evaluate the effectiveness of greenery that is there, encouraging buildings to use their rooftop space, their walls, common areas, incorporate as much greenery as possible into the building. And the type of species that is used as well, of plants, is very important, because various types of plants have different greenhouse gas capturing potential. That we should not discount indoor environment quality. When we think of a green building, we always think about the external environment. The indoor environment is just as important. The well-being of the occupants internally, which can improve their productivity and well-being. And of course, some innovation and carbon emissions of development. We need to convert all the efforts that we've made into a common metric, and the tons of CO2 equivalent is what is used universally. So it is important that we quantify all these efforts that are done in utilizing that metric. Okay, next slide. So this has been covered earlier as well. As I mentioned, the UBBL 38A, which has been gazetted in a few states, covers these major components. OTTV, overall thermal transfer value, which is the heat ingress through the facade, through the skin of the building. And we should try to minimize that to reduce the cooling penalty on the heat transferred in. So that's for the facade, and then we look at the roof as well. The roof is the most exposed to the sun. So by using materials with U values that do not exceed the limit set, we can limit the amount of heat coming in. Okay. Now, when we talk about greening commercial buildings, I will start off first with passive design. I think this is the cheapest way to limit the energy use of a building, but it has to be thought of early on in the design. It is cheapest when it's thought of early on. It becomes very, very expensive if you try to incorporate or change the way the building is designed passively later on. Okay, before we move on to active. Now, what do I mean by passive design? Okay, firstly, the easy kill would be the orientation of the building. In Malaysia, most of the heating occurs in the east and west. The west particularly because more of the day is exposed to heat in the evenings. So we should try to orient the building away from the west or reduce the amount of window area that we have on the west facade. Some other creative ways could be to move typically what is building core items like your lifts, your staircases, circulation areas to the edges of the building rather than putting it in the middle. And then your offices and all that, you try to incorporate it either in the middle or towards the north and south of the building. These simple strategies is a design parameter that can be, put in through by the architects, can already reduce up to 5% of your energy consumption of the building. Next, we should try to harness as much of natural ventilation as we can. In Malaysia, most of the prevailing wind is from the north and south orientation. So we design our openings, the windward and leeward, to face the north and south direction. We can maximize capture of natural ventilation. Apart from that, we can use things like stack ventilation. This is where hot air is generally quite buoyant. So we have louvers at the top of the building or some sort of extract mechanism. We can encourage air movement within the building. We should also start thinking, I think we encourage architects to, atriums which need not be air conditioned. They can be passively designed. Circulation spaces like corridors, why should we be air conditioning this? You can actually achieve a lot of good thermal comfort through shading and natural ventilation. And that's what we try to capture through our certification standards. Okay. Of course, as I highlighted earlier, overall thermal transfer value, this is a function of heat conduction through the walls, through the windows, and of course, the biggest component is solar heat gain. So if you want to have full curtain wall design, a lot of glass, then you have to spend a lot on reducing the SC value and U value of the glass. But even easier would be to just reduce your window to wall ratio. Why do we need so much glazing? So this doesn't have to be an expensive component. Achieving an OTTV value of below 50 is not difficult. We just need to design a building for its intended purpose properly. Okay, and 30% of your cooling requirements actually is coming through heat ingress through your building facade. So by capturing OTTV is very important parameter, because by reducing the heat through the building, you have a very strong likelihood of reducing your air conditioning sizing. U value, as I mentioned, this is a measure of the insulating properties of the materials that are used in your roof. I won't go into too much detail on this, but effectively you can see the difference between incorporating a little bit of insulation onto a concrete roofing structure and the dramatic improvements in U value that can be seen. I don't know, on my screen, the bottom one seems to be blanked off, but I think you can see it all. Daylight harvesting to reduce the need for artificial lighting. Of course, this has to be carefully designed so that it doesn't bring in too much heat. So we look at ways in which you could use light tubes or some sort of glare reduction strategies to bounce light into the building effectively. So this is an important thing to consider. And then we move on. So that is passive. If we move towards active design, of course, we cannot eliminate air conditioning altogether in a tropical country. So it is important that we move for more energy efficient designs. So we use a metric called kilowatt per ton. So this is the amount of electrical energy required per ton of cooling, air conditioning cooling. And we encourage buildings to move towards more efficient designs. There may be a cost premium, no doubt. However, the return on investment can be as low as 2 to 3 years. Okay, especially for larger buildings that have an air conditioning tonnage of more than 500 tons, we encourage them to go for centralized HVAC system, not to go for split systems. Centralized HVAC systems can give you a better efficiency. Okay, lighting, of course, many of you are familiar with LEDs and T5. I think this is something that has proliferated the market quite substantially. And I think the cost of incorporating or using these solutions is almost on par with less efficient technologies. So that is what we should aim for air conditioning as well. By creating economies of scale for more efficient equipment, we can make the more efficient equipment the de facto standards. Okay. And then of course, apart from using efficient lighting, we should also think about how we zone it and how we switch and turn it on or off. Simple things like using motion sensors or photo sensors, motion sensors in areas where there's less, where people are not frequently using, so lights turn on only when you're there. Photo sensors maybe in the perimeter of the building, so that in the office, the tables or people seated closer to the windows don't need to leave their lights on. That can be switched off automatically. And then of course, we should not have lighting zones that exceed 100 square meters. This way, you are more likely to switch off the lighting when you don't need to use it. If your entire floor has only one switch, then just because of one person using the building, you're going to be turning on the whole light fitting. So careful zoning is also very important. Lifts, of course, next biggest contributor. So now we encourage AC variable voltage, VVVF lifts, and also lifts that incorporate sleep mode so that they shut off and they're not in use. Even better, for high-rise buildings, we have regenerative lifts. This uses braking resistors to sort of capture some of the energy that is utilized during the lift operation. And this can be used to power most of the lift controls, thereby reducing and in fact even sometimes pump back to for your building usage. And this can reduce the energy consumption of the lift by up to 20%. Okay. Once we've tackled energy efficiency, then we can look at incorporating things like solar PV. This is getting cheaper and cheaper by the day, and there's a lot of incentives, especially net metering that is available. Our rooftop potential in Malaysia is tremendous. We shouldn't be thinking of large-scale solar. We should really be looking at using the available rooftop space for solar PV. The cost per kilowatt peak is currently, for installation, is now at about 3,000 to 5,000 ringgit. This was at about 20,000 ringgit just about 3 or 4 years ago. So the prices are dropping, and this is almost like a no-brainer to incorporate into any building. Okay, and of course, energy management system. This is another component that is part of the UBBL 38A. For commercial buildings that are more than 4,000 square meters, it is mandatory to have an energy management system. This is basically like a central brain. that is able to control, change the set points, obtain readings, obtain feedback, and optimize the use of all the active equipment in the building. This is something that should not be discounted. It can be expensive to incorporate, but once again, the more we can measure, the more we can control, the better we're able to operate the machinery. Okay. And once we have all this, we can perhaps move towards zero energy buildings. This is something that is being encouraged in Singapore, and there's no reason why we can't start this off here, especially in urban centers like KL and PJ. Once we have brought the building usage down to a level where it can be replaced by renewable energy, particularly solar, we can fast approach net zero and perhaps even move towards net positive buildings. So that should be the direction we move towards. And of course, all this, the bulk of electricity in Malaysia, 90% is still generated from fossil fuels. So by reducing electricity usage, we can reduce the impact to the environment through CO2 emissions. And on top of that, it's going to save you money. So this is the low-hanging fruit, the easiest way to tackle environmental concerns over CO2 emissions, and which also has a business case. I think this is something we should definitely tackle. Well, and as we move on, of course, water efficiency, as I mentioned, Malaysians are one of the largest users of water in the world. In fact, we use 30% more than the UN recommended guidelines. We use between 220 to 240 liters per day, and this is potable processed water. So there's new SPAN is looking to introduce this WEPLS scheme to make it mandatory. WELPS, we use it as part of our certification calculation. So as many of these fittings should be specified into a building from the onset. Okay. Rainwater harvesting, I'm sure everyone is aware of this. In fact, this is mandatory in 6 states. Many people question the usage of rainwater harvesting in Malaysia, but we should look at it from a bigger picture. We use potable water for a lot of tasks like watering our plants and washing our cars. And as urban centers grow, we can reduce the need to build water processing facilities, which has a tremendous energy impact. So that's how we should be looking at it holistically. I know we are blessed with a lot of water, but in the long term, it is still, or globally rather, it is still a scarce resource. And if we can, something that's cheap to integrate and utilize effectively, it should be done. Okay, environmental protection, I think this is a big topic when it comes to materials and sustainable construction, but I'd like to focus particularly on our use of cement. Cement production is responsible for up to 5% of our globally produced CO2 emissions. And there's many ways in which we can reduce the use of OPC. There's a lot of industrial byproducts like GGBS, silica fume, fly ash. In fact, most of the major cement manufacturers are able to integrate this into the cement mix, up to 30% replacement without sacrificing the integrity of your concrete. And this is there's very little price premium for this. So we encourage as many building developers to specify this, replacement of OPC with industrial byproducts. This has tremendous ability to reduce our CO2 emissions apart from energy consumption. Okay, and of course, indoor environment quality, run through very quickly. This is your thermal environment, your lighting, your sound, and of course air. With the current COVID pandemic, I think it is imperative that we focus on this. I think one of the reasons tropical countries have had reduced rates of COVID is because of the fact that we have better ventilation here, more natural ventilation in our buildings, which dilutes pollutants, and this should be encouraged as much as possible. Natural ventilation is the easiest, the cheapest way to enhance your indoor environment. This can also lead to reduced sick building syndromes and absenteeism and something called presenteeism also, where people are there but not really there. So the productivity is not quite at the right level. Okay, just to summarize it, I think we can look at Wisma REHDA, which is our headquarters. We have incorporated a lot of the features that I mentioned. We have the orientation is that it is south-facing to capture natural ventilation. The west facade is where we put most of the toilets and everything, so there's no offices on the west. And we've also reduced the amount of windows on that side of the facade. So it's only 0.8% of your facade area. The OTTV is well below 50 watts per square meter. We have energy efficient fittings in the building. So the EEI is below 100 kilowatt hours per square meter per year. We have extensive natural ventilation and daylighting. More than 60% of the floor area is naturally ventilated. There's a large water efficient, all the fittings are well rated, and also make use of the rainwater harvesting system. And there's also a renewable energy system, solar panels installed on the roof. In fact, I need to update this slide. We now have 70 kilowatt peak of solar panels installed on the roof, which replaces up to 10% of the building electricity consumption. Okay, so to summarize, this is the framework by which we assess it. I think we can move to the next slide. Everyone talks about the cost premium of going green. I think this slide is only reflective if we continue to design buildings in the same way, then yes, there will be a premium because we are still looking to cool the building as much as possible, use a lot of glass. That's why maybe a platinum building costs 8 to 10% more than a typical building in terms of gross development cost. However, if we start rethinking the design, reducing the window to wall ratio, creating economies of scale for better products, there doesn't need to be a premium to go green. Okay, and the benchmarking that we use, of course, is the Malaysian standards 1525 for commercial buildings and 2680 for residential buildings. We need to have a baseline by which we measure the performance when we talk about green buildings. So we should definitely encourage as a minimum buildings achieving the Malaysian standards before going green. Okay, with that, I think we've run a little bit over the time. Thank you for listening, and if you have any questions, please feel free to contact us at greenari.org and or call us. I will share the details with the presenters later today. Okay, thank you.